A very good afternoon to one and all. Today I am Dr. Pallavi Patil. Started with the same topic, that is chromatography separations. With this topic, we will see the next topic of this subtopic. Now, what is we say that a longitudinal diffusions, as well as how we are designing the width of the peak on the basis of their baselines, then diffusion of solute and the diffusion coefficient of solute in the stationary phase and the mobile phase. Before that, I just want to say that with this formula, we have already seen this average linearity velocity, then multiple pathways, then also we have seen also the band broadening. Now in this band broadening, there are the different aspects very correlated with this. First, the correlation, that is the longitudinal diffusion terms. Then the second is the multiple path effect. Then the thickness of the stationary phase, as well as the width of the peak. So these are the factors are very close together. Including this, if we are considering the mass transfer term, definitely it is also affected with the decrease the particle size. Now decrease the particle size, or we will see the decrease the thickness of the stationary phase, then the flow rate. These are all parameters which is very correlated to the band broadening. Including that, the dm. What is the dm? dm is a very correlations with the diffusion of a solute in the mobile phase. If this diffusion are constantly increased, we will see the mobile phase velocity moving from the one side to the another side of the column is affected. So let's see with this formula. H is the capital H is the band broadening. Now including this we will already we have seen in the fourth type of lecture and the fifth type of the lecture. So in this liquid chromatography, we will see how the H is affected with these factors. So in this, the longitudinal diffusions, we will see with this formula. We have already seen the longitudinal diffusion formula: average linear velocity, multiple pathway, and the thickness, width, and the Gaussian's curve is related to the variance that we have already seen. So these symbolic abbreviations repeatedly will come, and this will be affect to your calculation and statistical parameters. But the longitudinal diffusions are probably seen in the gas chromatography rather than the liquid chromatography, because the gas is a decrease continuously when it is carry the high velocity. The diffusion of solute in the mobile phase get affected. Now with this formula, with the same formula, that is H is equal to capital A plus B upon V capital plus C V. Now what it affects? It affects, and it's symbolic represented of van der Waals equations. Now in this equation, what is stated? They are contributing to the band broadening. Now in these equations, we will see how it is so much importance in the liquid chromatography. A is represented the multiple pathways through which a packed effect. V is what? The average linear velocity. We will measure in the centimeter per minute. Then the B is for the longitudinal diffusions for the moleculars. Then C is account for the resistance to the mobile phase or mass transfer. So how the mass transfer of analyte in the stationary phase and out of the stationary phase. Whether the interactions are required, definitely the interactions are required towards a more stationary phase than the mobile phase. So it is affected much more. If as well as the flow rate is affected, and how the column is having. What type of the column you are having, what type of the flow rate is having, definitely it affects the plate height. If the high flow rate, so definitely it not covered the completely plate height. So it is a better than the more height is not necessary. The less height, minimum height is the required for the flow rate. So it can cover the entire area to move on. As well as if the small platelet, the resulting we will see that the narrow chromatographic band and the better separation. So this is very much important ki what type of the height of the plate you are selected, how the flow rate you are getting control, and which type of column you are considering in the form of the stationary phase. The stationary phase needed, the mass transfer resistance is some concentration is required. The interaction in between the solute and the stationary phase is needed. On this basis, we will see that your chromatography result and the separation of components is a very good way. Now these are the term A, term B and term C. Now we are representing depending on the flow rate how it's get affected. If we are seeing now the A is for the multiple pathway. We already seen how we have to calculate this and how we have to use to just check out your band broadening in the liquid chromatography. Then B also we also discussed in the last previous lectures, and the C also we have already discussed a lot of time how it is much more important to get a better separation in the chromatography. Now with these effects, this is the resultant, and H is much more affected when you are concerning the flow rate. So these are a correlation with each other. Optimized flow rate is definitely affected with the term A, term B and term C. So the particle size. The particle size and flow rate as we have discussed already in this. But in case the H, that is band broadening, is not much more dependent on the particle size. But yeah, the H is dependent on the flow rate, but the flow rate is 100% depending on the particle size. The particle size is less, the flow rate can be goes smoothly, less absorptions happens and moving it be somehow faster. But the requirement of the solute and the stationary phase is happening when the particle size is less. And the faster separations can achieve the higher rate, but it's definitely affecting the band broadening. So with this point, you have to notate that the flow rate is dependent on the particle size. The particle size is not as much dependent on the band broadening. So this is how you are seeing that the H, that is a band broadening, is definitely affected on the flow rate. How it gives a different type of sampling, but increase their particle size. Increase the particle size. This is goes of slow flow rate. This is goes high flow rate. So yeah, these are the very correlated with each other. And when these are correlation, they are affected to the band broadening. What is the resolution? Resolution a very good chromatographic separations at the end you will find. When the two chromatographic peak you are going to measure and how they are separated from each other, you have to count in that way. So how the two peaks in the figure belonging, no any trouble identifications, and in that the best resolutions how you are seeing there are a lot of examples, the good resolution, bad resolution, poor resolution. But when the two identical peaks separated with a sufficient resolution number, we are accepted only that resolution of the two chromatographic. Now how these chromatographic peaks you have seen on your screen, look, these are the poor resolutions. These are merges A or B. If you have two components in the mixtures and these two components are together, they are not easily separated from each other. As you see that these are merged with each other in the A. Now if you are looking at the more separations, now these if you have taken considerations and you are doing a lot of trials with the same type of consideration, that is consideration of point means what? You have to consider the average linear velocity, you have to consider the multiple pathway, then band broadening, height of the theoretical plate, retention factor or capacity factor, as well as diffusion of a solute in the mobile phase, diffusion of the solute in the stationary phase, a thickness of the stationary phase, as well as these parameters, retention time, distribution constant, then concentration of solute in the stationary phase, concentration of solute in the mobile phase. So these parameters you have to keep in your consideration, and most important, what type of the mobile phase you are selected, what type of the stationary phase is selected, what type of the mobile phase having a polarity and it's needed a polarity more less, then you have to select the stationary phase. The stationary phase is also same like this. You have to go through the repetitions of the trials, and end of this you can improve this peak towards this. So this peak is also somehow good, but you have to betterly improve the peak, like where if these peak are not accepted because the distance in between resolution is not as accepted. The resolution have a certain standard value and you have to catch that value as per the ranges of the standard. So we have to say this is an excellent chromatography separations and a very peak resolution. This is a lace band and the lace band is spreaded. Now this is a very isolated from each other and get intimated to separation. So you can also measure the center of the point so you can find out the retention time. Here the retention time get confused with this because they are merged together. Here is more confusion. So that's on the basis of this we see the poor resolution, more separation possibly, but a less band width. If you are concerning the band width is definitely very much important when we are concerning the chromatographic separation of a 2 compound or 3 compound. And the note down the resolution have their fixed number with the after the calculation we have a resolution in way, so we will see the resolution. So like this, the same way. Okay, so this is we can find out the solutions. Now in this way, how you find out the theoretical plates? The theoretical plate means the number of theoretical plates present in the stationary phase. The stationary phase have a defined theoretical plate. Now we will see. If you are seeing the liquid chromatography, you can see the Hplc, and Hplc means high performance liquid chromatography. We have these systems or the software is actually everything is automatically. So in this the stationary phase they have a number of theoretical plates. More number of theoretical plates are very much needed to your better separation. But if the less number of theoretical plates, it's definitely affect the chromatographic separation. This is a very poor separation if you are seeing the less number of the chromatography. Now how you find out if you don't know the any type of the which type of column you are using? You just know the length of the column and the name and the type of column, and you have to find out your column what type of the number of theoretical plate and how much theoretical plate is available in the stationary phase. So what you have to do? You have to go with the two formulas. With this final result will come to your screen, and how you are designed. This is the component A and this is the component B. So component A is defined the Tm. We have already seen the Tm is the retention time in the mobile phase. Okay, so this is a width of your peak. So we have to consider the width of the half peak. Okay, so these are the standard formula, and this is the TR, the retention time of the stationary phase, retention time of the mobile phase. Okay, so on the basis of this, the generated formula is a 16 into TR, the retention time in the stationary phase, retention time in the mobile phase of the solute. Okay, and the width square of this. Okay, so the N is 5.54 TR, but this is the half. Now this is the half of which way. Okay, so these two formula, and on the basis of these two formula you are easily calculated the number of theoretical plates. You don't know whether you don't have any information whether the theoretical plates is more than a 5,000 or 3,000 or less than the 2,000. Except the less than the 2,000 number of theoretical plate is not at all accepted. It should be a very much more than the close to the 5,000 is very good, but more than the 5,000 is also accepted. Nowadays everything is automatically, and these formula when you are putting the values of your peak area, peak width, peak height and TR, TM, so this is automatically find out your number of theoretical plates, and you can feel that this is good for your separations, so you can continue your further procedures. Thank you very much.